Hello, folks. Today we are going to start talking about sequences and series. Sequences more specifically. Objectives of the lesson are to understand what an arithmetic sequence is. We want to be able to find recursive formulas for arithmetic sequences and explicit formulas for arithmetic sequences, whatever that means. So we're also going to learn what recursive and explicit means in this context. Now, before we get started, what is a sequence? Well, maybe a sequence is something like this. It is just a set of numbers, typically with some sort of pattern that connects them. So we're going to be looking at arithmetic sequences today, and let's go ahead and get started. So, this is a motorcycle that I rented from a guy here in town last year, Suzuki V-Strom 650. And with this rental, there were specific prices laid out for how I could rent this based on how many days I was renting it for. I have those prices listed here. 1 day was $135, 2 days was $268, 3 was $401, and 4 was $534. And we have a couple questions here. Based off of this model, how much would it cost to rent the bike for 5 days? Well, take a look at these numbers. If you want to know how I could get from 135 to 268, well, I could add $133. And from 268 to 401, that also follows that same pattern of adding $133. And from 401 to 534, that as well also fits that scheme of adding $133. So the indication here is with each additional day, I will be adding an additional $133. And so if I add an additional $133 to the fourth day's $534, I will get $667 for the fifth day. Now, what about 7 days? If I want to know how much it costs for 7 days, and then maybe I could figure out how much it costs for 6 days by adding an additional $133 to that last number, which would get me $800. And then I could add another $133 to that $800 to get the cost for 7 days, which would put me at $933 on the 7th day. And that was fine. It wasn't too much work, just adding 133 a bunch of times. But what if I wanted to know how much it cost after 2 weeks? I don't want to add $133 7 more times to get from 1 week to 2 weeks. So a better approach would be to come up with some sort of a model that would represent this. So let's think about what we're doing here mathematically. Let's start with this $135, the original amount. To get the cost for 2 days, I had to add $133 once. To get the cost for 3 days, I had to add $133 to the original twice. To get the cost for 4 days, I had to add $133 3 times. For 5 days, I had to add it 4 times. For 6 days, I had to add it 5 times. For 7 days, I had to add it 6 times. So my guess would be for 13 days, I'm going to have to add it 12, or I misspoke, for 14 days, 2 weeks, I'm going to have to add it 13 times. And what is it? 13 is, or it rather, is the $133. I will be adding 13 $133 to get from day 1 to day 14, which is 2 weeks. And so if I use this model right here, I can take 135 plus 13 times 133 to determine that it will cost me $1,864 to rent this motorcycle for 2 weeks, which is like crazy absurd. You could buy a cheap motorcycle for that cost and probably have just as much fun, and you'd own a motorcycle, so that would probably be a better route. But the point is, we're able to come up with this mathematical model there. We should see that this is certainly related to a linear equation because we're increasing by $133 each day. But let's think a little more specifically about what we did. Now what I'm going to do is I'm going to let n represent the number of days. I'm going to let d represent the $133 additional cost each time. We can call that the common difference between each day. And what else do I know? Well, I know the common difference was 133. And how did we think about this? We said that the amount that we had after n days was equal to that initial amount, $135, plus one less than the day number times that 133. So 135 plus 133 times one less than the day number. Well, one less than the day number, if n is the day number, one less of n is n minus 1. And so we came up with this model right here, 135 plus 133 times n minus 1. And let's check it on our other values and make sure that this actually works. If we want to know how much it cost on the 5th day, that first value we found, well, let's plug in the numbers that we know. 135 plus 133 times n minus 1. Here n would be 5, so we get 5 minus 1 like that. And if you crunch that in your calculator, you'll see that we do indeed get the appropriate $667 for the 5th day. This is an arithmetic sequence. An arithmetic sequence is a sequence, meaning it is a set of numbers that has a relationship such that each increasing term, each greater term number, is either increasing or decreasing by a set amount, that common difference, 133. And so in this way, it is much, much simpler to come up with this formula and use it rather than crunching out piece after piece. If I wanted to know how much it would cost after 2 months of rental, first off, that would be ridiculous to rent a motorcycle for 2 months. But the point is, you could do it, and it would be much better than crunching each number, adding 133 a bunch of times. So let's look at another one here. To graduate our school, you need to gain a total of 100 community service hours. Upon entering her sophomore year, Penelope had already earned a total of 31.75 hours. So if you think about what that means, if she has already completed or earned 31.75 hours, she has 68.25 hours remaining. Now Penelope is going to volunteer in my office hours. It's very nice of her. And let's think about what Penelope needs to continue through and finish up her community service hours. Well, here's a little model for you. I'm not telling you explicitly how many hours she volunteers each week in my office hours, but I am telling you that after 1 week of volunteering, she has 66.5 hours remaining. After 2 weeks, she has 64.75 hours remaining. After 3, 63, and after 4, 61.25. So we can use the same idea as the last time. We can find a common difference. And if you take term 2 and subtract term 1, so 64.75 minus 66.5, you can see that we are decreasing by 1.75 hours. It would work the same way if you did 63 minus 64.75. You would also get a subtraction of 1.75. Similarly, for this last one, we're decreasing by 1.75 each time. So, assuming this pattern will continue, how many hours would remain if she assisted for 10 weeks? Well, again, I could go through and I could subtract 1.75, a few more times and get to the 10th week, but I would much rather come up with a formula like we did in the last time. So, if you look at week number 2, we have subtracted 1.75. If you look at week 3, we have subtracted 2 1.75s, and at week 4 we have subtracted 3 1.75. So again, we have this relationship where the term number, the week number, is 1 greater than the number of subtractions we have applied. I don't know how to say that grammatically. But anyways, we can say then that the value of the nth term, a sub n, will be the value of the first term, 66.5, this time minus 1.75, the common difference, times again that n minus 1. That same relationship is holding true. So if we want to know how many remain after 10 weeks, well, we can say a sub 10 equals 66.5, the initial amount, minus 1.75 times n, which is 10 if it's 10 weeks, minus 1. And we can crunch that number, and you should find that after 10 weeks, Penelope will have 50.75 hours remaining. So a sub 10, the 10th term, is 50.75. Now, at this rate, how many weeks will she need to volunteer to reach her 100 hours? Well, that's like saying, let's figure out what the value of n is if we know the nth term is 0. Because notice, we're talking about the hours remaining, so if there are 0 hours remaining, she has completed her 100 hours. So let's say 0 equals 66.5 minus 1.75 times n minus 1, n being the number of weeks. And let's go ahead and solve for n. So let's say 1.75 times n minus 1 equals 66.5. And then we can say that n minus 1 equals 66.5. Whoa, that's a 0.5 right there. Divided by 1.75. And similarly, I can add 1 to both sides to get rid of that minus 1, and I have n equals 66.5 divided by 1.75 plus 1 will give me 39 as the value of n, which means if she continues to work 1.75 hours each week, she will have completed the remaining hours she has to volunteer after 39 weeks. This is the idea of an arithmetic sequence. It is essentially a linear function where we're talking about the independent variable being n, the term number, and the dependent variable being the value of the nth term, in this instance the hours remaining. So again, let's just kind of debrief what we did in an implicit way. A couple things to know about arithmetic sequences. First off, when you're talking about an arithmetic sequence, we're talking about addition or subtraction between your terms. And it has to be consistent between each term. We need to have that common difference. So the first term is denoted a sub 1, and the second term a sub 2, the third term a sub 3, etc., the nth term a sub n. If you wanted the 74th term, it would be a sub 74, and notice how I'm saying that, a sub, whatever the number is. The common difference, denoted as d, is found by subtracting a term from the previous term. So, for example, the third term minus the second term would get you your common difference. You always do the greater term number subtracting one less term number. Alrighty, what else? Well, with an arithmetic sequence, you can represent them either recursively, like we did at first, or explicitly, like we did when we came up with that smarter formula. Well, what does that mean? It means if you're doing a recursive formula, you are relying on a previous term to get your next term. To know what a sub n is, you have to know what a sub n minus 1 is, and you have to know the common difference. So for example, we can identify here 5 minus 3 is giving us a plus 2 for the common difference right there. So we know d is 2. And since we know the fourth term, a sub 4, we can say that a sub 5 equals a sub 4 plus our common difference of 2. And a sub 4 is 7, so we get 7 plus 2 equals 9. And that should make sense to us intuitively that we get 9 right there. That is a recursive formula. It uses the previous term to get the next term. Now, that's fine, but if you want to know information about terms farther down the line, you're going to want to use an explicit formula, or sometimes referred to as a general formula. Now, notice all we need to know is the starting term and the common difference, and then we can identify any term thereafter just using that value of n. And this is the pattern that we recognized to answer those questions earlier. So, since we know the first term, a sub 1, we could find the fifth term, a sub 5, by saying a sub 5 will equal the first term, a sub 1, plus the common difference, which again, 5 minus 3 is 2, times n minus 1. And n is 5, the fifth term, 5 minus 1, right there. So substituting in, a sub 1 is 1, so we get 1 plus 2 times 5 minus 1 is 4. We get 8 plus 1 is 9, just like we found recursively. The recursive formula should always match up with the explicit formula. The explicit formula is just more convenient to use. So there you have it. This will always work for any arithmetic sequence where you have a common difference between your terms. Now, the remaining problems are your homework for tonight. So what I'd like you to do is, as I put the problem up, I want you to try it, and then pause the video, try it, and then I'll go through a solution for you. So here we go. Here we go. So find the indicated term by first finding the explicit formula. So we want to find the 12th term of this sequence, given the term is 2, 4, 6. See what you can do, and I'll be back in a moment. Alright, let's talk about it. So what I like to do when I do these problems is I like to write the term number underneath the actual term. So the first term is a sub 1, second term a sub 2, third term a sub 3. Now let's figure out our common difference. We can tell that we are increasing by 2. If it's not obvious to you, do 6 minus 4 and you get 2. And notice that 4 minus 2 is also a positive 2. So we want to know what the 12th term is. And so we need to say that the nth term will equal the first term, 2, plus the common difference, which is also 2, times n minus 1. So if we want the 12th term, if we want the 12th term, a sub 12, we need to have the first term, 2, plus the common difference, 2 times n, which is 12, the 12th term, minus 1. And so we get 2 plus 2 times 11 is 2 plus 22, and we get 24 as the 12th term. Now, go ahead and do this one as well. Find the 10th term in this explicit, find the, I can't talk, it's late, 10th term in this arithmetic sequence by finding the explicit formula. So pause and go. Alright, well, we're going to do the same thing. We're going to say the nth term, a sub n, will equal the first term, a sub 1, which has a value of 1, there's our first term, plus our common difference. Well, what is our common difference? Well, we need to do d equals negative 5 minus negative 2. Gives me d equals negative 5 plus 2. d is negative 3, and that should make sense. From negative 2 to negative 5, you are subtracting 3, so our common difference is 3. So we're going to get, instead of a plus there, let's write it as a minus 3 times n minus 1. So if we want the 10th term, a sub 10, we'll get 1 minus 3 times 10 minus 1. And we can simplify things. Ooh, that's not a 2, that's an equal sign. Equals 1 minus 3 times 10 minus 1 is 9. Equals 1 minus 3 times 9 is 27. So 1 minus 27 is negative 26. And again, if you work it out recursively, you should get to the same exact answer. Alrighty, well, let's move on to something a little more complicated. Now we want to find the first term of the arithmetic sequence given the information below. And we also want to write a recursive formula for it given what we have. So what do we know? We know the 8th term is 8, and we know the 20th term is 44, and we're told it is an arithmetic sequence, which means we are going from n equals 8 up to n equals 20, which means we are covering 12 terms between 8 and 20. Think about what I did there. I did 20 minus 8 equals 12. Now, in those 12 terms, how far have our term values jumped? Well, there our term values have jumped from a sub 8, our 8th term having a value of 8, up to our 20th term having a value of 44. So again, I can say 44 minus 8 is giving me 36. So I have increased 36 in 12 terms. So if 12 terms increase me 36, how much does each term increase me? Well, 36 divided by 12 is 3. And so 3 then has to be my common difference, D. So let's write a recursive formula. So we will say a sub n equals a sub n minus 1 plus our constant difference d. Whoa, change of colors. Plus our constant difference d. And so a sub n equals a sub n minus 1, the previous term, plus 3. That is our boring recursive term. Recursive formula, I should say. Now, what do we want to do? We want to find the first term of the sequence. Now, I could just start at the 8th term and subtract 3 7 times to get to the first term, but that's kind of lame. And if I was given, say, the 500th term and the 700th term, and I wanted to find the first term, well, that would be a lot of subtraction to do. So instead, what I'm going to do is I'm going to write an explicit formula for this. I'm going to say a sub n will equal my first term, a sub 1, plus my common difference d times n minus 1. And now I want to substitute in what I know. Let's do this. Let's use the 20th term, and the value of the 20th term is 44. So we can say that 44, the 20th term, equals the first term plus my common difference, which is 3, times n, which I'm doing the 20th term, minus 1. And I can solve this for a sub 1. So 44 minus 3 times 20 minus 1 is 19 equals a sub 1. And we can crunch that real quick. 44 minus 3 times 19, and we get negative 13 for the first term. And so we then can say we have the explicit formula, a sub n equals, that should say negative 13. A sub n equals negative 13 plus 3 times n minus 1. And we could verify that this works for the 8th term. We can say a sub 8 equals negative 13 plus 3 times 8 minus 1. And if you crunch this, you will in fact get 8, verifying that our formula is in fact good. So let's move on to this final problem that we're going to look at together. Find the first term given this information. So please pause here, do this problem on your own, and then I can show you my solution. So pause. Alright, you either paused or you waited a few seconds like I did in sheer silence. So let's do the same exact thing. We want to find the first term and we want to write a recursive formula. So we can determine that between 13 and 5 terms, from the 5th to the 13th term, we have gone 8 terms to get from the 5th to the 13th. And we can determine that in those 8 terms, we have covered a distance of 30 minus negative 2 is 32 numbers between those 8 terms. We've increased by 32, and so we can figure out that 32, the value of our increase, divided by 8, the number of terms, will give us 4 as our constant difference there. We're increasing by 4 each time. So our recursive formula is a sub n equals a sub n minus 1 plus 4. Nothing to it. But again, let's write an explicit formula. A sub n equals our first term, a sub 1, plus our constant difference times n minus 1. And let's plug in one of our terms. Let's plug in 13. Well, the value of the 13th term is 30, equals the value of our first term plus our constant difference of 4 times n, which is the 13th term, so 13 minus 1. And if you crunch those numbers, well, I guess we're not really there yet, so let's say this. 30 minus 4 times 12 equals a sub 1. And if you crunch those numbers, you should find that the value of the first term is negative 18. So a sub 1 is negative 18, which means our formula, explicitly written, is a sub n equals negative 18 plus our constant difference of 4 times n minus 1. And we can verify that this works by checking our fifth term. So a sub 5 will equal negative 18 plus 4 times our fifth term, so n is 5 minus 1. And you can do this one in your head. 5 minus 1 is 4. 4 times 4 is 16. Negative 18 plus 16 is, in fact, negative 2. So we have verified that this works. And now the last thing I want you to do is look at this problem. The Drury Lane Theater has 25 seats in the first row and 30 rows in all. Each successive row contains one additional seat. So the second row has 26 seats. The third row has 27 seats, etc., 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 all the way up until you hit the 30th row, which has a blank number of seats. And the question is, how many seats are in the theater? And while I'm modifying the question, I'm going to give you the answer. I'm telling you there are 1,185 seats in the theater. What I'm challenging you to do is to determine how do you get that answer other than just adding a bunch of numbers together. How do you get this without adding 30 numbers together? Because that's kind of obnoxious to do and doesn't really tell us anything mathematically. So I want you to try to find a number in the patterns that will allow you to use the terms and the value of the terms and the number of terms to come up with the sum of the terms. So give it a shot and we will talk about it next class.